In this video, we're going to look at what happens when our axis of revolution is not either the x or the y axis. So in previous examples like this one, you have y equals x revolved around y equals 0, the x-axis here. You would be looking at the r of x as the distance between the shape here, the outermost portion of the radius, and the axis. And so in this case, c happens to be 0 because it's y equals 0. And the outermost portion of, say, for example, if we're looking at this shape right here, would be x minus 0, or x. If you're revolving around some line that is above your shaded region here, so this triangle is my shaded region, the outer portion of my washer, r of x, is going to be whatever c is, in this case 7, minus whatever the outermost radius is, which in this case is 0. So that would make my capital R of x be 7. There's an outer kind of cylinder that's being formed here. And then the part that's being erased from it, the whole of the washer, little r of x, is going to be c minus whatever the portion of the shape is. So in this case, that ends up being 7 minus x. It's the distance from here to here. And because we're talking about a distance, you want that to be a positive amount. So if you're looking at a vertical axis of revolution, it's going to be a similar concept. If c happens to be to the left of the function or of the shape, then you're going to want to take whatever this value is minus c, whereas if c is to the right of it, you would say c minus whatever the function is, in this case something like y equals x. So if the axis is greater, you subtract the axis minus whatever curve is forming the boundary of the shape, and if the axis is less than the value of the region, you would want to say the boundary of the region minus c. So this example says find the volume of the solid of revolution formed by revolving the region bounded by x equals 0, x equals 2, y equals x squared, y equals 0, and y equals 4 about the line y equals 4. So I'm just going to sketch out my graph. So this is the region that I'm looking at, and I want to revolve it around the line y equals 4. So you can see that this is a region that is less than the axis of revolution. So my capital R of x then is going to be equal to c, which is 4, minus the outermost portion here of what's boundary is forming this shaded region, and that would be y equals 0. So it'll be 4 minus 0, which is 4. And then my little r of x for this shape is going to be the distance here, and that part is variable. Little r of x is going to be c, which is 4, minus whatever the height of the shaded region is, which it happens to be x squared in this case. So now when I go to find the integral, which is going to give me my volume, I'm going to use that same formula for the washer method. V equals pi times the integral from a to b of r of x squared, capital R of x squared minus little r of x squared, which will be pi times the integral from, in this case, x equals 0 to x equals 2 of 4 squared minus 4 minus x squared squared. So I'm going to do some algebra on this, and so that I can integrate. That gives me 16 minus, when I FOIL this out, I get 16 minus 8x squared plus x to the 4th. And when I distribute and simplify, I will have 8x squared minus x to the 4th. The 16s cancel out. So that's going to be pi times 8/3 x cubed minus x to the 5th over 5 from 0 to 2. And we'll have 8/3 times 2 cubed minus, let's see, 2 to the 5th over 5. And then that's going to give me 0 and 0. And doing all of the arithmetic for this, you should get 224 over 15 pi units squared. This example says to find the volume of the solid generated by revolving the regions bounded by the graph of the equations y equals square root of x, y equals 0, and x equals 4 about the line x equals 6. So in this case we have a vertical axis of revolution, which we can see is to the right of our graph. It's larger than our graph. So we are going to be looking at r of y here. And because I want things in terms of y, I'm going to square both sides and get that y squared equals x. So that's the version of that we're going to be using. So for capital R of y, we're going to go from here all the way out to whatever the outermost portion of the curve is. And in this case, that's going to hit the function here. So r of y will be c minus f of y, which in this case is 6 minus y squared. And then little r of y, the whole of our washer here, little r of y is going to be c minus whatever's forming this curve. And that happens to be x equals 4. So 6 minus 4, which is 2. So the volume, which is pi times the integral from a to b of r of y squared minus little r of y squared dy, will be pi times the integral from, our shape goes from 0 to 4, of 6 minus y squared squared minus 2 squared dy. So that's going to give me 36 minus 12y squared plus y to the 4th minus 4, which is going to be pi times the integral from 0 to 4 of 32 minus 12y squared plus y to the 4th dy. So when I integrate that, I'll get 32y minus 12 over 3 is 4y cubed plus y to the 5th over 5. And that's all from 0 to 4. So we'll have 32 times 4 minus 4 times 4 cubed plus 4 to the 5th over 5. And then when you plug in 0 to each of these, you get 0. So simplifying the arithmetic, we will have, and so when you do the arithmetic, you end up with 384 over 5 pi. Now each scenario may be a little bit different, but if you remember that capital R of x is the distance from your axis to the outermost portion of the shape, and little r is equal to the distance from your axis to wherever the gap stops, and try to make that value positive depending on whether the axis is below or above or to the left or the right, then you can figure out what your capital R and your little r need to be based on the situation that you're given.